Well, L'Hopital's rule works just as well for one-sided limits as it does for two-sided limits. So let's talk about number 11 on page 454, which reads, use L'Hopital's rule to evaluate the one-sided limits. Support your answer graphically. So for part A and B, we have the same function, sine x over x cubed, but for part A, we're going to approach the limit from the negative side and go to 0, and in part B, we're going to approach 0 from the positive side. So we've been talking about and reminding ourselves about how we have a number of ways to find limits, and one of the first things to do is graph. And the instructions actually tell us to support our answer graphically, so we might as well start by graphing. So when I graph this, I get something that kind of looks like this. So it looks to me like the limit is going to go to infinity from either side as we approach 0. So let's see what actually happens when we do this. Now, we'll just start with part A, but it's going to be a very similar process for A and B. So for A, we're going to take the limit as x approaches 0 from the negative sign, and we're going to have sine x over x cubed. Now, if we just substitute in, which is our next method when we're looking at our list of ways to evaluate limits, we're going to take the sine of 0, and we're going to divide that by 0 cubed. And the sine of 0 is what? 0. So we're going to have 0 over 0. All right, that means that we can apply L'Hopital's rule because we have one of the acceptable indeterminate forms. And just to remind ourselves, L'Hopital's rule says that the limit as x goes to a of f of x over g of x is equal to the limit as x goes to a of f prime of x over g prime of x, assuming that this first limit here goes to an acceptable indeterminate form, 0 over 0 or infinity over infinity. So we've got one of those forms, and we can apply L'Hopital's rule. So this is going to be equal to the limit as x goes to 0 from the negative side. And when I take the derivative of sine x, what do I get? Well, I get cosine x. And we're going to remember that we're going to take the derivative of the numerator separately from the derivative of the denominator. And what do I get when I take the derivative of x cubed? I get 3x squared. And my next step is always to go back and try substituting in and seeing if applying L'Hopital's rule just once is able to resolve my issues. So if I substitute in 0 again, I'm going to get now the cosine of 0 over 3, 0 squared, and the cosine of 0 is what? 1. So I'm going to get 1 over 0. And that is actually an answer, because what is 1 over 0 equal to? Well, it's equal to infinity. And that really is what looks like is happening with my graph. All right, well, part B really shouldn't be any different, but let's look at it anyway. So now we're going to take the limit as x approaches 0 from the positive side. Still going to have sine x over x cubed. Still going to substitute in, and I'm still going to get the sine of 0 over 0 cubed, which is going to give me 0 over 0, which means I've satisfied my condition for L'Hopital's rule, and I can apply it. So I'm going to take the derivative, and I'm going to have the limit as x goes to 0, now from the positive side, of sine x over x cubed. And I'm going to take the derivative of that. So I'm going to have the limit as x goes to 0 from the positive side of cosine x over 3x squared. And when I substitute in, that's going to give me the cosine of 0 over 3 0 squared, which is going to give me 1 over 0. And like we said, that's an acceptable answer. That's infinity. And that looks like where the limit is going if we look at the graph.